So in the classwork activity, you should have filled out this diagram and you should have found that triangles tessellate, quadrilaterals tessellate, and hexagons tessellate. Okay. And anything else did not tessellate, any of the other regular polygons. Okay. And we should have found that if we did a triangle, we got 6 of the vertices to match there. And if we do the 60 degrees times 6, we get 360. And we should have found for a quadrilateral, there were 4 that matched. And if we did 90 times 4, we got 360. And for the hexagon, it was 120. And so we put 3 of those together because 3 times 120 is 360. So we found that those 3 shapes tessellate, but the other ones did not. And the other ones do not is because their interior angle does not divide into 360 evenly. So if I take 360 and I divide by the interior angle of a pentagon 108, I get 3.3 repeating. And so that means I need 3 1/3 of the pentagons to meet at a vertex. And that means I would either have to have a gap or an overlap. And there's no way that that pentagons will meet up at a vertex to completely cover the plane. Right? And the same thing for a heptagon or octagon. If I take 360 and I divide by that interior angle, I'm not going to get a whole number. But if I do the triangle and I do 360 divided by 6 or 60, the interior angle, that is going to give me 6. And so that means I have 6 triangles that meet at a vertex. And therefore it will tessellate because they will completely cover that vertex and therefore completely cover the plane if I keep duplicating them. Okay. So the question we want to ask after we know that the 3 regular polygons that always tessellate are triangles, squares, hexagons. The question is, do all triangles tessellate? Do all quadrilaterals tessellate? Do all hexagons tessellate? And so I'm going to show you examples and then explain why or why not for each of these. So the first one is do all triangles. So here I have an isosceles triangle. Here I have a right triangle. You can see that on both of these, I get 6 triangles to meet at the vertex, and they definitely tessellate. And you found that the equilateral triangles tessellate. So it's impossible to draw every possible type of triangle to show you, but all triangles do tessellate because the 3 angles of a triangle add up to 180 degrees. So what I can do is I can duplicate a triangle 3 times and then put each different angle together. And those 3 angles are going to add up to 180 because the 3 angles in a triangle add up to 180. So those 3 angles can come together to make a 180 degrees straight angle. And if I put another 3 triangles together, I get another straight angle, and I can put those 2 straight angles together, and 180 plus 180 is 360. So therefore, all 6 triangles can come together to make 360 degrees, which means the triangles tessellate, or any type of triangle will tessellate because the 3 angles in a triangle always add up to 180. So I can always create a straight angle with 3 of the triangles and always cover a vertex with 6 of the triangles. So that's our triangles. The second thing is quadrilaterals. So I drew a few pictures. Here I have a rhombus and it tessellates, 4 of them meet at a vertex, a rectangle, 4 meet, a parallelogram, 4 meet. I tried my best to draw kites that were similar. It's not the best, but they meet at a vertex and they tessellate. And so again, it's impossible to draw all the different type of quadrilaterals, but all quadrilaterals will tessellate. And the reason that all quadrilaterals tessellate is because the sum of the angles of any quadrilateral is always 360 degrees. Remember, we did the sum of the angles. Interior is 4 minus 2 times 180, which is 360. So any quadrilateral, the angles add up to 360, which means I can duplicate the figure 4 times, and I can put the 4 angles of the quadrilateral together, and they will always add up to 360 if I pick one of each angle to meet there. And therefore, the quadrilateral will always cover the vertex with no gaps or no overlaps, and I can tessellate it. And so all quadrilaterals also tessellate. So if we fill in, we have all triangles tessellate, yes. All quadrilateral tessellate, yes. And then the last one we want to see is a hexagon. So one thing to remember with a hexagon, if I do the sum of the interior, we do 6 minus 2 times 180, which is going to give me 720. Okay, so one thing to note is 720 does not divide into 360 like the sum of the quadrilateral interior angles and the sum of the triangle. And here I have an example. So if I look at this example, this is a hexagon, it has 6 sides. It is called an irregular hexagon because all the sides are not equal. And if I try to put these together, if I do it this way, I have an overlap. If I try to fit one of the smaller angles in, I'm going to have a gap and an overlap. Same with this one. So there's no 2 angles that I can put together to not get a gap or an overlap in this hexagon. And so this hexagon does not tessellate. Okay. So do all hexagons tessellate? No. Since the sum of the angles is 720 degrees, you may not be able to find angles that add to 360 degrees. Okay, so some irregular hexagons do tessellate, but not every single one. I gave you a counterexample here. So when we're asked if all hexagons tessellate, we say no. So the only 2 shapes that always tessellate are triangles and quadrilaterals. Okay, and then again, regular hexagons tessellate. And an irregular tessellate hexagon may or may not. And they recently found an irregular polygon, an irregular pentagon that tessellates. You can look it up on the internet if you're interested. But so some pentagons tessellate, but not everyone. So to go to that question in the packet, question 1 in the packet, it says, considering angles, how do you know whether or not a regular polygon will tessellate the plane? What we do is if you do 360 divided by the interior angle. Okay, and again, we're doing 1 interior angle. It has to equal a whole number. If it does, then the polygons tessellate. Okay, so again, when I do 360 divided by 60, I get 6. And so it's a whole number, it tessellates. 360 divided by 90 is 4, and it tessellates. That's a quadrilateral. 360 divided by 120, which is the hexagon's interior angle, gives me 3, and so it tessellates. But if I do again 360, so let's say if I tried like a 13 gon, and I found the interior angle, which is 13 minus 2 times 180 divided by 13. Which gives me 152.3. And even now we have a decimal, so it's going to be pretty obvious that this doesn't work. But if I do 360 divided by 152.3, okay, and I rounded that, I get like 2.36. And so a 13 gong does not tessellate. And this method is only working for regular polygons. Okay, it has to be regular to check it this way. But that's how we determine if a regular polygon tessellates. We do 360 divided by the interior angle. If it's a whole number, it tessellates. If it's not, it does not tessellate. And then you should have done question 2 on the classwork activity for your packet. And so if you have any questions, let me know, but that is tessellation.